Hello, Wharton students. Welcome to Introduction to Computer Science with Python. This is Lecture 0, where we'll solve the mysteries of what programming really is and why it's such a crucial skill in today's world. Today's agenda covers 3 main points: understanding computer programs, diving into Python and its advantages, and getting started with Python's basics. First off, what exactly is a computer program? A computer program is a set of instructions to a computer on how to solve a problem. It's not just about writing code, it's about translating our logical solutions into steps a computer can execute. Now, let's dive into the process of programming. Think of it as telling a story where each piece of code plays a part in solving a puzzle. Sometimes, these puzzles are straightforward, like making a video game character move. Other times, they involve more complex scenarios, like adjusting a game's background in response to the character's movements. Just like following a recipe to cook a dish, writing a computer program involves detailed steps. Let's look at how we might cook the stir-fry shown in this photo. Take vegetables out of the refrigerator. This is similar to initializing variables in our program. Set them on a cutting board, just like setting up our workspace in a coding environment. Chop them up, the equivalent of breaking down a problem into smaller, manageable functions. Put oil in the pan, then vegetables, sequential instructions that our program must follow. Accidentally burn them, order takeout. Sometimes our code doesn't work as intended, and we need to debug or find alternative solutions. This sequence sounds straightforward, yet programming requires specifying even the smallest steps. A computer needs every detail, from identifying what qualifies as a vegetable to the action of chopping, ensuring the computer recognizes and processes them correctly. To make our coding lives easier, we often use existing code libraries that provide predefined functions, like a preset vegetables list. This way, we don't have to start from scratch and can build upon others' work to solve problems more efficiently. So maybe someone else wrote a code, defined vegetables, and has a whole bunch of vegetables that include all the ones that we might need for our recipe. We could just import that code and then keep going, and then refer back to whatever we've imported or use the syntax or terms in that code. There are lots of ways to program. One of them is to write entire programs from scratch. But here's the catch. A computer needs very specific instructions. Skip a step or get too vague, and your program won't work as expected. It might even crash. This is why programmers spend a lot of time debugging, which means finding and fixing errors in the code. An efficient approach to programming is using existing code. Instead of starting from scratch, we can use libraries, packages, or pieces of code created by others to help solve our problems faster. This not only saves time, but also introduces us to a variety of coding techniques and solutions. Programming is both a science and an art. It requires logical thinking to break down problems and creativity to find unique solutions. So, how can we become coding masters? First up, make coding part of your daily routine. Just like your favorite sports or video games, the more you play, the better you get. Remember, always write the code yourself instead of just copying and pasting. It helps you understand and remember better. And if you're up for a challenge, try writing code by hand on paper sometimes. But it's a fantastic way to get the logic down pat. Also, learning by doing is key. You wouldn't learn to swim by just watching others. Dive into those exercises, get hands-on with the example code, and try things out yourself in a blank notebook. As you learn to program, you'll discover that trial and error is an invaluable teacher. Don't be afraid of making mistakes or encountering errors. Each mistake is a learning opportunity, helping you become a better problem solver. Finally, keep practicing. The more you code, the more intuitive it becomes. Then what is Python? Python is a popular programming language developed by Guido van Rossum in the late 1980s. It is known as simple, uncluttered, meaning not filled with unnecessary functions, and fun to use. Let's discuss more on why many people use Python as a programming language. First of all, Python is a high-level language. Its syntax is clear and readable, using English words and phrases, which helps make our code easily understandable. As a general-purpose language, Python is versatile. It's used for various tasks in programming, from web development to artificial intelligence, making it a one-stop language for many projects. Python is also interpreted, meaning you can write and test small pieces of code quickly, which is excellent for learning and experimentation. It's free and open source, so anyone can use it and contribute to its development. This has led to a vast collection of libraries, tools that you can use to do specific jobs. Some of these, like NumPy and Pandas, are incredibly useful for scientific computing and data analysis. The more people use and improve it, the better it becomes. This welcoming and collaborative environment is one of the many reasons we've chosen Python for this course. Here's a list of other programming languages. JavaScript, for instance, is primarily used for building websites and plugins, making the web interactive and dynamic. Python, which is one of the fastest-growing languages, is easy to learn and applicable in AI development. Java is usually chosen for developing large systems, databases, and Android applications. PHP is for website development, however. It is not widely used anymore because it is too slow and inefficient. C# is a Microsoft-developed language bearing similarities to Java. C++, a language that was developed in the 1970s, is essential for browsers and games due to its high efficiency. TypeScript has stronger type checking and was created by Microsoft. Shell is essential for automating commands and tasks within an operating system. The C language is one of the oldest computer languages. It is essential for systems-level programming, forming the backbone of many modern operating systems. Finally, Ruby is known for its simplicity and the popular web framework Ruby and is used for application development. Each language has its unique niche. As you can see in the graph, Python is the most used language in the world, which proves that Python has a huge role in various programming fields, especially machine learning and AI development. Let's begin our journey with Python. Where do we write and execute our code? That's a fundamental question as we step into the world of programming. There are several environments known as code editors or integrated development environments, IDE, where we can write, test, and debug our code. Let me introduce three popular IDEs. First, there's PyCharm IDE, which has a strong debugging features. Next, Google Collaboratory, or Google Colab for short. It's a free, cloud-based platform that allows you to write and execute Python in your browser with no setup required. Lastly, we have the Jupyter Notebook, an open-source web application. We'll be using Google Colab in this course. Let's try it out. Begin by typing Google Colab in the search engine. Once you find the official site, click on the link, and you'll be taken directly to the Colab environment. Click New Notebook. You can change your file name. Let's say Practice. Leave .py and b at the end. This file extension is to identify the Python file. Let's test it out. Let's type 3 + 2 and hit the Run button on the left. After a few moments, you will get the result. Cool. You can also create a text line where you can write a plain text. The more pound signs, the smaller your text gets. You cannot put a plain text and code in the same block, so you would have to create another code block to write a new code. Now, let's save our file. Go to File and then hit Save. If you click the Colab logo, you will see your file saved in your Google Drive. Thank you for watching this overview of our Python course. In our next lesson, we'll dive straight into coding. See you next time.